觉得可以了
？OK 了，
没问题了。
好，谢谢。
这些是OK 了。Alright, so for our last stage, stage 4, we will start now. And again, the opponent will challenge the reporter with the problem.
So we want to try problem 5. So we are
the presentation, please.
Okay, so I'm a reporter from TYPT. My name is Chen Shiwen. Today I'm going to report problem number 5, ping-pong rocket. First, this is our outline. And here's the problem statement. So a ping-pong ball is placed on a container of the water. When the container is dropped, the ping-pong ball will get launched and to a great height. What maximum height can you reach with it? Up to 2 liters of water. So we want to mainly focus on the maximum height. How can we calculate or test it out? And here's our observation video of our phenomenon. Okay, so in this phenomenon, we use tracker to analyze this motion, and we can catch. So this part is where the bottle and the ball drops, and this part is where the ball bounces. So we mainly track on the ball, the center of the ball, and since there has a gap, it's because the ball doesn't touch the bottom of the cup. So the height won't go to 0. And then we analyze the velocity of the ball. Okay, notice. So this is the velocity when it drops, and it bounces, and bounce to the, and bounce, and then just keep falling like this. So we have several experiments. Want to explain this phenomenon. Okay, so the first experiment, we want to know the correlation between water mass and bounce height. So first we do some calculation. So we assume that this model as a collision model. We assume it. And so we have the conservation of momentum and a conservation of energy, like this. And after calculation, first we define R. It's the ratio of the mass of cup plus water over the mass of the ball. We divided this, we call R. Then we can calculate the velocity of the ball that it released is this. And VI is the initial velocity of where the ball just bounce, just start to, when the whole system just touch the floor, and there's the initial velocity, we define it. And since V equals square 2GH, so we can calculate the H bounce out. Then, so since we have this result, then we can make a graph of the ratio, and you can see it seems like that. So it has a convergence when the R increases here. Okay. So this is our experiment variables. So we manipulate the mass of the water, we control the mass of cup and release height and the type of the ball. And the response variable is the bounce height. Here's our experiment design. So we have a tube or something, then we have a hole just around it. So we can at very first we can catch the bottle and the ball. Then we release it and we make it fall and make it just going upward, and we can measure. So here's our setup. So first, our release height is 40 centimeters. And the mass of ping-pong ball is and the mass of cup. So here's our experimental result. When we change the water volume and we have different bounce height, it just forms like this. And since it forms like this, and we turn to the ratio of it, then we apply our theory into this. So we move our theory line trying to fit this our result. And why we have to move? So first is the horizontal one. Maybe it didn't really use most of the energy or most of the force of the whole system. So we have to move it horizontally. And the vertically is because of the energy loss. So here's our second experiment. We want to know the correlation between release height and the bounce height. So from a photo, we know this, and here's our schematic diagram. So we just release our cup and a ball, and we make it drop and make it go upward, and we measure it. So here's our experimental variable. So we manipulate the release height, and we control those things, and we want to know the bounce height. So here's our result. So when we have different release height and have different bounce height, and we can consider it as linear. So through the slope and r squared, we can consider it as linear in this region from 30 to 70 centimeters. We can make sure that it's linear. Okay. So we try to use the collision model to explain this phenomenon. And since we know the release height, the ratio of release height and the bounce height, we can calculate the resolution of coefficient. So we define our resolution. Resolution of coefficient is the h bounce over h release and squared. So in our experiment, we measure that the E ground means the bottle, when the bottle, only the bottle drop and go back. The resolution of coefficient is 0.35, and we can further calculate the E water. It means like when the ball just when whole system drop, and why this such complex, because we have to consider the velocity of those two things, and we have to calculate it. And so the E water means the ball, and the ball when the whole system drops and when it goes back, so the ball will just bounce up, and we calculate it. From this equation we can know this. Okay, so the third experiment, we're trying to know if we change our containers, how would the bounce height affect? So here's our setup. So we change the type of container, but we control the total mass. It means the mass of water plus the mass of container. Because in our previous experiment and previous model, we add the mass of water and mass of the bottle together to calculate it. So we control this, and we control the ball height. So here's our different containers, and this is the weight of those containers. Then we analyze our data. So here's the bounce height of 4 different bottles, and we're trying to find some correlation between those containers and the bounce height. So we found out that we define the mass ratio is the mass of this plastic bottle divided the mass of a testing bottle, or we call it testing bottle. So like this, for the ratio of the big plastic bottle is 44.56 divided over 7.5. And we found that the correlation between the mass ratio and the bounce height is a linear and a negative correlation. So so why does it? Whether does it form like this? We think it's because due to the collision and the force that just affects on the ball, then it will affect it. So when will the maximum height ratio happen? So in our previous theory and experiment, we can get this equation. So in ideal conditions, means if we assume that the E water and the E ground equals to 1, then the maximum ratio, height ratio, can become up to 9. But in reality or in our experiment, it's definitely not the ideal condition. So like we apply E ground as 0.35 and we calculate our E water. And so in our experiment, in our theory, the max ratio of the bounce height is 2.89. Okay. So first, wait. But in our experiment, we test out the maximum height of the maximum ratio of the bounce height is going to approximately at 2, and we think it's because of the energy loss. So here's our summary. So we analyze the bounce, and we try to fit our theory to our experimental result, which there are some like deviation, and we try to know the height, release height and the bounce height, and we calculate our theoretical ratio of bounce height and release height and depth.
Okay, so question from the
Okay, so thanks for your presentation. So first, I want to ask, do you control the position of the boat every time you drop?
We're trying to fix the point, but since
So you control the boat at the center of maybe the area?
no, because it was just
Okay, so I will discuss later. So do you control the angle between the ground and the container?
we didn't really.
Okay, let's discuss later. So because you say that you have control the mass of the whole system, so because you use different kind of maybe container, right?
Right.
So you consider that the mass of the boat or the mass of the container would affect.
Since we didn't change the mass of the boat,
Yes.
but we found that the mass of the container may be relative to the boat.
I got it. So you always use the same ping pong ball to control the mass. They are the same, right?
Right.
Okay. So So do you try to know that the depth that the ping pong ball sink into the water?
We didn't really measure it.
Oh, okay. So how about do you consider that it will affect, or you didn't consider that? Just because I mean that the depth.
The depth, I think it may be affect.
Okay, I got it. So because due to that, you always use the same ping pong ball, so the contact area will all be the same.
When at the experimentally we didn't fix the area,
Okay.
but
So
in the previous one we fixed it because we used the same container.
okay. So do you consider that the angle between the ping pong ball and the water surface would affect?
How can you define the angle?
Probably the angle.
This is a sphere.
Maybe you can try to know the tangential line to draw a theta between the surface and the ping pong ball. Do you consider that you would?
So you mean when it sinks?
Yeah.
Let's go.
Oh, okay. Thanks.
3 minutes for the opponents presentation. will give the speech now. Please.
Okay, so I'm from TYPT. Today I'm as a opponent. So we challenge the problem 5, the ping pong right here. So when the ping pong ball is placed in a container of water, when the container drops, the ping pong ball will get launched to a great height. So I consider the report has to the main variable is to know that the maximum height. So the summary of the report is a conservation of the momentum and energy, and they define the restitution coefficient, which they try to calculate the bounce height and the initial height. And then they have a lot of feeding data to prove that their data is maybe correct. And for the experiment, they use main parameter, so the mass of the water and the releasing height, and the type of container. And for that, they use a pipette to control the flow impact. But just I asked an actual question, I didn't consider that the report has control the angle between the container and the ground. So I will be discussed later. And for the result, the release height is linear to bounce height, and the maximum height ratio is about 2.89. So for strength for a reporter, so I consider the reporter has done some simple explanation and understand the task, and also control the mass of container because they use different containers, but they control the mass. So it would be to know that how may the material of the area of the container will affect. And for suggestion, I consider the report has to do some clear explanation for a specific physics process, because they didn't really explain more about the physics process behind the phenomenon, and they need to explain more about energy law, just because they define the restitution coefficient, but they didn't really talk about more about why it would like not very accurate. So they didn't control the contact angle, and they didn't consider the pressure wave. So for discussion later, so first I want to ask the angle contact the ground, and it's the ball at the middle of the container. Just from my perspective, I consider the position of the ball will also affect, just because I consider there will be some energy loss to the maybe container. And for mechanism, I want to ask the physics process behind this phenomenon, and about where the force and why there's support or the energy transfer from maybe the ground or the water to the people. For method, I want to know how the energy actually transfers to the process. And the data analysis, well, what's the height of the unit of a student press, and for a reason that behind the limit of height. So that's my floor. Thanks. So first, I want to know traditional problem statement page. So this it's talking about the maximum height in Euclid. So can you tell me maybe the maximum height you have get in different variables?
Since because we found out that maximum height is relative to the height that we release, so we found out the ratio, but not the actual number of the height. And in our experiment, we found the maximum ratio of the height that we can get is 2.
Okay, so you say that the initial height will affect the maximum height. So do you consider another parameter that will affect this task?
I think the texture of my bottle.
Okay, I got it. So because the first statement say that with up to 2 liters of water, but could you change to a graph page, you use a different volume of water. So this implies you only just reach the 200 water volume. So do you consider that if you use more water volume, what would it affect this phenomenon?
It would just increase slightly since it just started to converge.
So it would so you consider that the water volume would have a convergence, or it will have a peak to the maximum height.
I think it will have a convergence.
Okay, so how about you explain this phenomenon why there is a convergence? So because I consider maybe the ball may control the position to the container, so the height will also be affected.
So here you say you consider.
So I consider when you use more water volume, you say that you consider the release, the bounce height will to a maximum, right? To be convergent. So do you know that? So what's your opinion about the physics process behind this phenomenon? So that will converge.
Okay, so in my opinion,
Yes.
I think when we use the same containers,
Yes.
So the area is set.
Okay.
Okay, so when I add more water in it,
Okay.
so it only changes the depth. So in the very beginning part of, at the very beginning, if we just add like few water,
Yes.
so the effect of the height is really.
So if you consider the like maybe the spout height would become increased just because about the depth of the hole.
Yes, because the energy that comes from the bottom of the bottle will be very significant when
Okay.
the height is.
Okay, okay. So would you please change to the problem statement page again?
Okay. Yep.
Okay. So because it's mainly talking about the maximum height. So I consider the contact angle with the container and the ground will also affect. Just because I mean that the ball would just like maybe the vertical just go up or be a projectile motion. Yeah. So do you consider that maybe the contact angle would also affect?
I think the contact angle will be affected. I know that maybe opponent wants to is curious about it because in our observation video there's some angle, right?
Okay.
Yes. So through we do many times of our experience. So we think we can consider it as the numerical error.
Oh, I got it. So I want to go to the blackboard. Okay. So I want to know about the basic process behind the I mean like you try to use Excel, but you didn't really explain more about the basic process.
So you want me to explain the process? If I release the bottle to the
Yes. So what would the different conditions would still in the air or you can tell the ground?
Okay. So at the beginning we can consider it as a system because it has the same
You
velocity.
mean still in the air or
Yes, still in the air. And when we touch the ground, okay, so this is our tube. So when I just touch the ground, then there's the collision situation between here.
Yes.
And there's some effect that maybe collision or something else effect to it. And then so after that, this bottle will just go up a little bit, very little, and the ball will just go up.
So just like you mentioned before, that is the position of the ball didn't really to go to the zero because it didn't contact the road.
Right.
Okay, I got it. So I consider because it's still water. So in my opinion, I consider it will be the buoyant force because it's staying in the water.
Okay, so in our observation, a one force maybe we just miss it, but I think it's not really affect much since it can be seen to go to the bottom of the bottom, and if the energy transfer from the whole system is more far bigger than the bio.
Okay, so to explain more about this phenomenon, because I don't know just when the ball can take a circuit, so how it bounces to the grid height. So is that what energy transfer or what the force causes?
Okay, so at the very beginning of the collision of when it just touched the ground,
Yes.
right? So since this is water, we can consider it as a rigid body, and since like the weight or something is time to transfer. So at the very beginning, when we just touch the ground, at first the energy transfer will just from here,
Yes.
and then later.
So you consider the force and energy as the ground for going to the container and water.
Going to a container. And
Okay.
so it just goes up to the ball, and at the meantime, the ball and the water will have some energy transfer.
Yes.
So ball got the energy from both water and go to the ground and go to the ball.
Okay.
So make it higher.
So how about the perfume jet? I can tell it maybe looks like this phenomenon.
Oh.
Yes.
Yes.
To explain about maybe the definition or the position of the washroom jet.
So we found out that moment, it will form like a shape like this.
Yes.
So here's surface tension, and here's air cavity, and here's collision. Just make it just go downward, and then the water will go back and make the Washington jet. So pull the ball up. So since we can know that it's relative to the height that we release, so we can, and this is like a square. So in our definition of our coefficient, we can just combine. I think we can just combine this together to have a new coefficient that we just measured in our experiment.
So do you consider that the working jet also applied to this phenomenon? Just like you will also be a jet. Just because in your experiment video, I may see like also a jet.
Yes.
Okay, I got it. So do you use a camera to observe that there will be an air cavity?
Can I draw it?
Okay.
So we use camera and we observe that at the first it will just go a little bit, and then it will just go far lower,
Yes.
and then it starts to form the yes, and then it goes.
So if we say like we consider the entry first from the ground to the container. So we also consider that there will be some entry first from the container to the floor. Because you mean like the water or the energy transfer. Right? Okay, I got it. So if you change your page like you use different container. Yes. Next page, go. Yes, so why the aluminum would got the minimum and the small plastic got the maximum?
So through this, right? So since the aluminum is the heavy,
Yes.
so it's so, and in our result found that it's
So
relative to mass ratio. But we also think that the elasticity of the container may affect it.
So since you control the mass of the whole system, right?
Yes.
But you say that the aluminum bottom is the more heavier. So maybe it depends on the water will be slower, will be less because of the Okay. So do you consider also maybe the shape or the radius of the contact area would also affect? I mean, just like you different to the previous picture. Yes. So because the radius of the contact area are different, so consider that it will also affect. Because in my opinion, because you say that the energy will also transfer from the container to the center of the bowl. So because the radius are different, so I can say it will also affect.
Yes. Oh, okay. So I think it might also affect, but I think it's not very obvious in our experiment.
Okay. So could you turn to page 9?
Page 9.
Yes. So could you tell me the value of the x-axis and the y-axis?
So since it's the ratio,
Yes.
so
So
when I just increase my ratio,
so the only one unit in here is B1 or the value of the ratio.
the value of the ratio.
Yes. So
Okay,
because
so
yes.
I'm supposed to forget to keep this.
Okay. So what do you consider that the ratio will be higher? Will be the to the conversion.
Into the converter. So
Yes.
since this, if my R goes to infinity, so we can consider it as like 3R divided over R.
So opponent will summarize the discussion.
Okay, so I asked the reporter about the variable that would affect the maximum height. So we also consider that the difference, the volume of the water and the mass of the bowl, mass of the container, and the shape of the container will also affect. And we also asked about the physics process behind this phenomenon. So I can say the report has done very good. I will explain the working jet and the high and the physics meaning behind this phenomenon. So the report say that because of the energy which transfer from the ground to the container and water, and also the energy which transfer from the container to the bowl. Yes, and we also asked about the contact angle, because that the maximum height will be the vertical, the perpendicular, or the projectile motion. So the maximum height will also affect. So I also asked about the force that would
position in the container affects important? Do you think it's important to the bombs?
I don't think it's really important to compare to the water volume.
I consider is the shape of the area of the container will affect because that the energy will lost during the energy transfer.
Okay, so do you think the immersion depth of the ball during the depth that the ball sinking in the water during the falling is affect the bomb?
Oh yes, since it forms a Washington jet, so the depth will affect. But in our theory and in
So
our
do you think the immersion depth changed during the falling?
so in our theory, we know that it's relative to the edge of the height of
No,
our.
I mean the ball, like there's the water surface and this is the ball, and I want to ask the depth.
Oh no, because this
So
we
you think
said
it
and it's
didn't
related so
change during the falling?
yes. Okay.
I consider the position didn't really affect much at the depth because the water volume increase, the depth would be maybe to the conversion. So I do consider the depth is the main reason to maximum height.
So if the ball doesn't remain in the center, do you think that's affect the height, the ball's height?
I don't think it really affects much.
I consider when the ball didn't touch the container, didn't touch the container, it wouldn't be really affect much.
Okay, so do you think the shape of the bottom of the container, like the bottom of the container, the shape of the bottom of the container affect the height?
I don't think the bottom affects.
Okay, after you.
I consider when the concentration would be different.
If the bottom isn't flat, is that affect?
Oh, sorry, you mean the shape or?
Oh, sorry. Yeah, I mean if it's flat or flat.
I think it will affect.
In my opinion, I think consider that is very matter to the maximum height.
So do you think the area of the bottom of the container affects?
It affects since I add the same volume of water in the maximum height, like the limit of.
So because the area will be less, the depth of the whole water will be height. So I guess it would affect to the middle.
Okay, so do you think?
All right, so time for the bureau to prepare for the speech.
drum, and the amount of water, which is the mass of water, and the drop height. Okay, so this is our overview of the report, and we think we have the calculation of energy momentum for solution and the parental theories of phase experience and discussion of this solution coefficient. And their experiments have they checked the position of the ball on y-axis, and they have their clear setup and diagram, and they determine max height, and then they have their meeting. So they have their theory and experience already. And the remarks to the reporter is they have the time management, and they try to fit the theory with the experience. And the suggestion is they should have provided a simple physics model, and they should consider the air resistance and the surface tension should be briefly calculated. And they have the variable control on changing the parameter only one at a time, such as they change the material of the container and the bottom area of the container at a time, and also the bottom shape. And they didn't control the interval between the bottom of the container and the ground. Okay, so there's the remarks to the opponents. They mentioned the contact angle, and they noticed that the conservation of energy and momentum may not be used. And they discussed whether more water volume always lead to larger time. Okay, so the suggestion is they should discuss the experiment's difficulties. Okay, so this is the question I asked, that is the ball's position in the container important to ball's height, and the reproaches is no, and the opponent says yes. So I think, in my opinion, the ball's height may depend on the mass of the water displaced by water. So I asked them that if they think the immersion depth of the ball changes during the flight, and they say it's just a little bit, but I think that the mission depth of the ball changes is an important point during the flight, because so I think they should prove that it only changes a little bit. And I asked them if the ball does not remain in the center, how does it affect the bounce? And they say the person says no, and the opponent says as long as the ball doesn't hit the wall, it won't matter. But I think that when the container touch the ground and the shock will raise up, the jet, the position of the jet and the position between the relationship between the position of the jet and the position of the ball is an important point. So the ball will bounce sideways and the vertical speed is lower, so I think it's a fact.
All right, thank you. So the reporter will give the concluding remarks.
Okay, so this is concluding remarks from reporter. So first is our first is our summary of our report. So first we use conservation of momentum and the energy derived formula, which is our experimental data. And then we use condition model and assume the elastic condition to get the coefficient of restitution. And we use the mass ratio of the ball and the top increase. When it increases, the height starts to convert. And the mass ratio of different containers increase. The maximum height starts to decrease. And the maximum coefficient of restitution is 2.89, which we got through our theory. And here's the discussion summary. So we discussed about the maximum height that we can reach and how to control the angle, and the physics process of the phenomenon, and the container material and the maximum height reached, and the discussion of the unit of the graph of this. So here's some concepts that have to be resolved. So first, the maximum height reaches will be a ratio to the release height. And the angle was used as an experimental error, so there we repeat the experiment a lot of times, so we can just avoid it. And the Washington jet and Washington launch the technical flow to a great height. And aluminum launches the lowest, it might be the cause of the water being the less. And the R reaches infinity, as R reaches infinity, so that's this. Can be viewed as R is 3R over R. And it will start to converge. Thanks.
Thank you very much. So, question from the jury, please.
Let me ask, okay. Do you think your theory can quantitatively describe your experimental data because you make several shifts?
So we found that our theory just we missed some points. So
yeah. So if you want to improve it, do you choose other theory or other things we should consider?
like maybe we can consider about like the Washington jet or the energy loss.
Okay. How about the
I
other
think they
picture?
can consider the immersion, the immersion depth of the water, and they can calculate the water that is.
Alright.
So I consider laboratory do more explanation about the energy transfer because they just use a coefficient resolution. And for Washington jet, I consider that there will still be some flows to the Washington jet because in their video I didn't really see the aircraft. Yes.
Alright. So. Alright. I think the more quantitative theory should predict why the Washington jet formed. Okay. Otherwise, you cannot make a very accurate prediction.
Okay, may I? You mentioned the container, the shape of the container. Okay. So have you considered this presentation of the containers to 4 different containers have different results compared with the maps? So do you think that's a reasonable assumption or that's not a reasonable assumption? Do we start from the visual?
I think if the
Please show the data. You'll consider the shape.
Consider the shape. This.
Yes. Can you show the data, please?
So since we
Well, I'd like to ask the reviewer
of course.
first. Okay. You see this diagram, right?
yes,
How do you think it? How do you think of shape?
I think the shape of the bottom of the container should be controlled when the material of the container.
Thank you.
So I got 2 points. First, because they have a different variable. So because when they use a different container, the volume will also be the volume of water will be also different. Because they say that they control the whole mass of the center. And could I use the black word?
Just give us the answer, please.
Okay, just because I consider maybe the circle will just make the energy convert to a jet. But when they report maybe use a rectangle, the energy will not only convert it to one jet. It may be many jets. Yes.
Okay, so I think it's my fault to not to control the shape of from this the rectangle one. But there I have been to make a graph for like the different area, and it's not we can't find any correlation between the area and the maximum height.
Okay, thank you.
All right, thank you. So,
Please ask if you change the for example, cross section for your hand.
Radius.
Yeah, the radius for the bottom is larger and for the top is smaller.
But you
You
mean
get a
like-
better result.
We haven't considered it yet.
I mean, you use different radius for the bottom is larger and for the top is smaller, and you get a better result. What's your comment? For the comment.
Does the mass of the water
Yes.
I think it affects because the shock waves is produced by the pollution way of the energy shift.
So I can say that will be more energy loss during the higher radius. Yes.
So the jury will see the scope of the water first. Grade for the reporters are 7, 5, 7, 6, 5. And the score for the opponent. The grades are 6, 7, 7, 8, 6. The grade for the reviewer